Right, so today we are looking at arguments. We are proceeding from where we left off. So we saw that when we looked at arguments, we discredited the idea that arguments is people that are, raising their voices. That's not an argument when we're looking at logic. And then we looked at validity, right? And when we ended, we just described what validity means. And now we need to look at ways that we can use to prove whether or not an argument is valid, right? So the first one is the truth table test, which you're going to look at. And then later on, we'll look at what we call natural deduction rules. Right? So the truth table, if you look at the truth table, we have already encountered the truth table when we looked at different operators. So we say that you have true, false leading to valid, or true premise, false conclusion, invalid, and so forth. This is a form of a truth table that we've already encountered. Right. But then if we are looking at, say, in the instance of a court case, right, we are evaluating to see each premise independent. Is it true? Is it false? If it is true, and then it is linked to a false statement, what is the net outcome of the argument based on the given premise? That is what we want to check. Right. And then we are going to look at one example. This is an extract from a past paper. Right. So it says, show that the following sequence is not valid by giving an appropriate valuation. So number one, what is the appropriate valuation to prove non-validity? Right. So there are multiple, right? But to prove that something is not valid, right, you are proving that you need an exhaustive approach that will let you know it's not valid. Right? When we look at natural deduction rules, I will explain to you why they are not the appropriate valuation to show you that it is not valid. So you need something that is robust, a procedure that is decidable to let you know that this is not a valid argument. Right. So I hope you haven't forgotten how to draw your truth tables. For this one, I'll go through it with you so that we can catch up. Right. So we want, firstly, to put our premise in. Right. So what are our atomic sentences? Right. Atomic sentences are true or false statements. So the joining of multiple true or false statements, which you have learned before, will then build up our premise. We've got one premise, we've got the second premise, and we've got the conclusion. So if we have the inputs is P, it's Q, and it's R. Right? So we've got P, we've got Q, and we've got R. Right? So these are the inputs. And when we draw a truth table, right, the number of rows we have are dependent on the number of inputs that we have. So the number of rows will be 2 to the power of n, where n is the number of inputs. So 2 to the power of 3, in this case, it will be 8. So we're going to have our 8 rows. 3, 4, 5, 6, 7, and the last one, 8. Right. So in these rows, what's going to happen, right? The innermost, right, is going to alternate the truth value at every 2 to the power of 0 interval, which is equals to 1. So after every row, it's going to alternate the truth value. And here you have to be consistent. If you start with false, you go with false. Across, if you start with true, I prefer starting with true. So I have true, false, true, false, true, false, true, false. Right. So over here, because I already started with true, I'm going to start with true as well. But then what's the difference? Here I'm going to change the truth value after every 2 to the power of 1. Right. What's 2 to the power of 1? That's 2. So after every 2 rows, the truth value changes. True, true, false, false, true, true, false, false. Then over here, we start with true. but then the truth value is changing after every 2 to the power of 2, which is equals to 4. After every 4 rows, the truth value is changing. True, 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 then change. False, 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 false. If we're going on, then we'll change at this point. But that's it with the inputs. Now we need to build up the given premise on premises. So let's start with the first one. So to build it up, we are going to build up gradually. We're just not going to do it all at the same time. So we have got a disjunction and an implication. Which one takes precedence? And if we were to apply brackets, where will they go? And the most binding of these two is a disjunction. So brackets will go here. So we build that one first. We want to build P or Q. Right. A disjunction, for a disjunction to be true, either P or Q have to be true. Right. If we just need one of them to be true, at least one to be true. So here P is true, Q is true, so it's going to be true. True, true, going to be true. True, false, it's going to be true. True, false, it's going to be true. False, true, it's going to be true. False, true, it's going to be true. False, false, none of them are true. False, false, none of them are true, therefore it's false. Right. Then let's build this whole one now. So we've got P or Q, and then we want P or Q implies R. That is what we want now. So we're now looking at this column and R. Right. So we now have true implies true. This gives us true. So we're now looking at the truth table for implication, which we said if we have, for example, PQ, I'm going to do a short version of it here. Right, we're going to have true, false, true, false, true, true, false, false. Then P implies Q will be true, false, true, true. Right. So over here we've got true implying false, it's going to give us false. True implying true is going to give us true. True implies false is going to give us false. True implies true gives us true. True implies false gives us false. False implying anything will give us true. False implies true is this one, and false implies false is this one. They give us an output of true. All right. Then we move on to the next premise. This premise is done. This premise is done. So let's move on to the next premise. So we're going to have not R. So we're simply negating the truth value that we have here. And to do that, we're going to have true is going to be false. False is going to give us true. True is going to give us false. Apologies. False, true, false, true, false, true. All right. Then we look at our final column that is going to be the conclusion, in which case it's Q. So we're simply copying what we had for Q. We had true, true, false, false, true, true, false, false. Now I want us to highlight, or we have done or built the truth table for this sequence. What then are we looking at? So from the definitions as per given, we have got the definition of a valid argument. We said it can be valued is valid on the basis of 3 different given premises. So if an argument, if you're using law of excluded middle, it means that an argument can either be valid or not valid. Right? If an argument is not valid, then by default it is valid. We know non-validity is easier to check because it is much more, or it commands a much more stronger way of proving it. Right? So to prove invalidity, what did we say? The premise have to be true. In this case, all of them have to be true, but the conclusion is false. All the premises have to be true, but the conclusion is false. So to prove non-validity, you go to your given premise. So this is P1 and this is P2. you are looking at where they are both true, P1 and P2 are both true in the same row, but the conclusion is false. So I come here, okay, true, false, okay, cool, I'm not interested. False, true, not interested. True, false, not interested. Not interested, not interested, not interested, not interested. True, true. Okay. I now have a scenario where all my premises are true. In that scenario, because it's one that counts, in that scenario, what is my given conclusion? My conclusion is false. Therefore, we can say this argument is not valid. So we have got one instance in the truth table that is proving that an argument is not valid. Even if we had another, for argument's sake, we had true, true here leading to true in row 1. Right? Even if we had true, true leading to true, but by virtue of us having an instance in the argument when the premise are true but the conclusion is false, then we can say the argument as a whole is invalid. So we can refine validity of an argument to say each time or every time that the premise are true, the conclusion has to be true. Every time that the premise are true, the conclusion has to be true. Okay. So that is the take-home point. The conclusion has to be true. Done. So now that is how we get, or how we apply the appropriate valuation of the truth table. Let's look at another instance. Right. So in this case, the examiner asked, you're given that scenario, show that the sequence is not valid by giving the proper valuation. So proceeded, we did Q, R, S, those are the three inputs. Okay, we build R implies S, there we have. So we've got true implies true, true, false, true, 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 false, right? As you can see, we are proceeding with our valuation. Right? Then that was the only premise that we have, fortunately or unfortunately. Then we have got not S implies not R. Not S would be, if you build, you can start by saying not S and then you have not R as individual columns. Then you can say not S is false. False implies anything becomes true. Not F is true, implying not R, right? So over here, we're going to have, what's this? Sorry, okay, over here. False, it becomes true, and then this becomes false, false, right? And then you can proceed and you can see that this becomes the outcome. Right? Then we build Q all that. So Q or that, whenever one of them is true, so it's already going to be true here, 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 without even checking Q. So where it is false, we check, okay, cool, it's true. So we gave it true. Where it's false, here it's false, so it's going to be false. And these are the only two times that it is false. So eventually we have only one false. Right? In which instance are the premise true? We have got the premise are true here, or the premise is true there as well, there, and there. Where it is true, is it also true? Yes. True, true, yes. True, true, yes. True, 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 and true. Right. So in this case, each and every time that the premise is or are true, the conclusion is also true. Right. So is something wrong? Because the question was asking not valid. Prove that is not valid. So when you look at equivalencies, right, if you draw the truth table of not S implies R and R implies S, right, you come to the realization that these two are equivalent. right? They are contrapositives of each other, right? And they are equivalent in the sense that they give you the exact same truth table outcome. So as you can see, true, true, false, false, true, 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 false, false, true, 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 true. They keep on giving the same result. So whenever this is true, this is also true. So it gives you, even without looking at Q, you can already see that this sequence is valid because there's no way that this is going to be true. And where we have got a disjunction here, it demands that if this is true, the whole statement becomes true. So in this particular case, the sequence is valid since all rows where the premise are true or the premises are true, the conclusion is also true. So I put a note there to say that column 5 and column 6 are equivalent to each other. Therefore, it would make sense for this that the sequence entails the conclusion. Right. So this was an exam scenario where you had the post is not valid, but then the solution came out as a valid sequence. Right. So now we've looked at one way it was not valid, and we've looked at one way it is valid. In this case, we failed to identify a scenario that makes it not valid, thereby declaring it valid. Right. So that's it. Let's meet in the next video.